Welcome to Little Stories Around Us, where you can relax, listen, and learn English through calm and meaningful stories. Sometimes the most powerful discoveries begin in silence, in a quiet laboratory where light, time, and imagination meet. The 2025 Nobel Prize in Physics celebrates three scientists who turned invisible mysteries into something real. Something that may one day change the way all of us live, think, and connect. John Clarke, Michel Devoret, and John Martinis have spent decades exploring one of the strangest, most beautiful frontiers of science, the world of quantum mechanics. It is a world where particles can be in two places at once, where energy moves in jumps, and where the smallest changes can unlock the greatest possibilities. Their research helped turn this strange world into a working tool, a foundation for what we now call quantum computers. These machines do not think like normal computers. They use quantum bits or qubits that can represent both 0 and 1 at the same time. This allows them to perform many calculations at once, making them thousands of times faster than today's best supercomputers for certain tasks. Imagine trying to find one specific book in a library of billions. A regular computer would search one by one, while a quantum computer can read them all at once. This is not science fiction. It's the reality that Clarke, Devoret, and Martinis helped make possible. In the early years, quantum mechanics was more philosophy than engineering. Scientists like Niels Bohr and Albert Einstein debated its meaning, wondering whether it described nature or just our understanding of it. But for these three modern scientists, the question was not, what does it mean, but what can we do with it? John Clarke, born in the United Kingdom, became known for developing extremely sensitive devices that can detect tiny magnetic fields. These instruments, called SQUIDs, superconducting quantum interference devices, are so precise that they can measure signals from inside the human brain or from faint cosmic sources in space. Michel Devoret from France brought a new level of creativity to this field, working on circuits that allowed delicate quantum effects to survive longer than ever before. And John Martinis from the United States combined both science and engineering to build real quantum computers, step by step, atom by atom. Together, their work turned theory into technology. It was not easy. In the quantum world, even a single vibration or a small burst of heat can destroy fragile information. Many times their experiments failed. Circuits broke, calculations went wrong. Years of effort sometimes ended in silence. But they kept going, guided by curiosity and patience, the same patience that has always driven scientific progress. Over time, their persistence paid off. Today, quantum computers are no longer dreams. They exist, not in every home, not yet, but in laboratories and companies around the world. They are being used to test chemical reactions, design new materials, and study the limits of encryption and security. One day, they might help predict diseases, simulate climate change, or solve problems that would take normal computers millions of years. The Nobel Prize Committee in Stockholm recognized this achievement, not only for what these scientists built, but for what they showed the world, that even the most abstract science can become something real, something that serves humanity. Their prize includes 11 million Swedish kroner, but the true reward is far greater, the transformation of imagination into technology. The journey toward this moment began decades ago in small labs filled with wires, magnets, and liquid helium. Students remember Clarke teaching them how to listen to the whisper of electrons. Devoret encouraged young researchers to find beauty in complexity. Martinez often told his team that every big step in science begins with a tiny one you don't give up on. These lessons, passed quietly from teacher to student, are part of why this Nobel Prize feels so special.
Behind every scientific discovery, there is also a story about human emotion, about patience, teamwork, and faith in invisible things. Imagine working for 20 or 30 years on something that most people can't even see. Imagine believing that the dance of particles smaller than dust could change how humanity thinks. That kind of belief takes courage, the same courage that pushes explorers to cross oceans or artists to paint what has never been seen. Quantum mechanics has always been mysterious. It tells us that reality is not as simple as it seems, that certainty is an illusion and probability is everywhere. For most of us, this can feel confusing. But for these three scientists, uncertainty was not a barrier. It was a bridge. It was an invitation to explore, to ask, what if we could use this mystery to do something good? Their answer, quantum computing, may one day reshape industries from finance to medicine. A quantum machine could analyze stock markets with perfect precision or model new drugs at the atomic level. It could make our digital world safer by inventing new forms of encryption. But more than that, it could change how we think about knowledge itself, reminding us that there are still infinite things we do not yet understand. As we listen to their story, we are reminded that science is not just numbers or machines. It is a human story, full of curiosity, failure, and wonder. It is about learning to see what lies beneath the surface of things. John Clarke once said in an interview, "Science is a conversation with nature. You ask, and sometimes, if you listen carefully, nature answers." That quiet humility, the willingness to listen, may be the truest form of intelligence, because even in a world of supercomputers and data, the real progress begins with one simple question: why? When the Royal Swedish Academy of Sciences announced the prize in Stockholm, the hall was filled with applause. But perhaps the most meaningful moment happened later, when the three scientists thanked their teams, students, and families. They spoke not of fame or fortune, but of curiosity and collaboration. "We just wanted to understand," said Martini softly, "and in trying to understand, we found something bigger than ourselves." Today, we live in an age where technology changes faster than we can follow. Yet the story of the 2025 Nobel Prize in Physics reminds us that true progress is not just about speed. It's about depth, about looking closer, thinking deeper, and daring to see what others cannot. Quantum computing is still in its early steps, but like every great idea, it began with wonder. And maybe that is the real lesson here, that even the smallest question, asked sincerely, can open doors to the universe. So next time you hold your phone or open your laptop, remember, somewhere, in a quiet lab, someone is still asking questions about the tiniest particles, believing that the answers will help us all. And thanks to Clarke, Devoret, and Martinis, the future of computing and of human understanding may soon be more quantum than ever before. If you enjoyed this story, please like, share, and subscribe to Little Stories Around Us to learn English calmly every week. See you in the next story, and take care of your dreams.